My name is Andre Durand. I am the project manager and water resources engineers for Triscuit Engineering. Today we are presenting our progress on our Crown Point Business Park Development project. Our client wants us to divide our land into 1 acre or larger lots, including a closed loop drinking water system, an urban road running through it connecting Maryville Road to Summit Street or Indiana Avenue, and the design will also include a mixed-use 40,000 square foot building with water quality best management practices on the lot. And now I'd like to hand it over to our transportation engineer.
Hi, I'm Mason. I'm the transportation engineer here at Triscuit, and for my presentation, I will go over the road alternatives, some trip generation, and intersection evaluation. So to begin, we have our first road alternative, which connects Maryville Road to North Indiana Avenue. There is a easement that goes through with power lines, so I had to curve the road to make sure that it avoids those. It is designed at 30 miles per hour to match Indiana Avenue and Summit Street, and it is our primary alternative for use, so the rest of the project will be designed around this. Our second road alternative connects Maryville Road with East Summit Street. So it also avoids the power lines, but this one runs through the gas and nearby the railroad, so it's not our primary use. So here's some trip generation, and our building will be divided into 2 floors to spoil Christians, which is apartments and a retail store. So using this, I found the average trips for each with the 9 units of the apartments and the 20,000 square foot retail store, which brings the peak hour trips to about 83 extra. And then there's some entering and exiting data, which is even for the retail store and more entering for the apartments at peak. So for just our parcel, I generated some turn movement predictions. So you can see that a lot of the turn movements will be going through the intersection at East Summit Street and North Indiana Avenue, and less towards the Maryville Road side. And then here is it adapted to all of the parcels that will be created. So just some predictions. You can see a lot going through the through street at the intersection, which is a common theme. So here is the first intersection evaluation for the East Summit Street at Indiana Avenue. And it is, with our parcel just being there, it is evaluated at a level of service C with the few that our parcel generates. You can see that this, the do nothing has the right turn lane at the same lane as the through street. So the second alternative has an extra right turn lane for use, and at the current, with just adding our parcel, this adds to a level of service B. Another alternative, since a lot of the traffic for all 4 entryways goes through the through traffic lanes, would be adding a through traffic lane, but then also keeping the right turn lane in the second through traffic lane, which would keep, with our parcel, the level of service at B. But with more additional parcels being added, the do nothing alternative makes it a level of service F with all the new trips. The adding the right turn lane would only increase that to a level of service E, so it's not as better, that much better. And then with the new through lanes, it brings us up to our goal of a level of service C, which makes it the best alternative so far. And then in the future, I will need to look at the parking design, as well as make a typical section cut and analyze the costs. And now I'll be passing it on to our structural engineer, Christian.
Good morning, good afternoon. My name is Christian Robinson and I'm the structural engineer for Triscuit Engineering. Before I dive into the different alternatives that I have available for us, I'd like to talk about my responsibilities for our project. One of those being creating conceptual floor plans for the different design alternatives we have, calculating a cost alternative for each one using our RS means data, and working with my team to determine what is that best alternative, and with that we'll be able to determine the best building location and the building orientation. Provided here is our minimum design dead load estimates. This was pulled from the ASCE 7-22. Since we were not given exactly what we wanted our building to be, it was up to us to determine what we envisioned our utility for that building would be. So some of these values we're taking from what we imagine will be contributing to some of the components for the different levels of the building here. This is going to be a living and breathing document, so there may be some things that are included that should not be, or some things that have not been included yet that will be added in and will be changed as we move forward with our different alternative progressions. Same goes for our minimum design live loads as well. It kind of spells it here, but tells us what we envision using our building for. So as Mason has stated, we design on using it, or intend on using it for more of a commercial / retail for our first floor, and then more of a residential space for our second floor. And then at the bottom, I decided to also include some of the different property values. There was one point in time where we considered maybe using concrete or lumber for one of the alternatives, but we have recently scrapped this idea, but we have since then just still kept it just to show the different property values for the different materials that may have been contributing to it. For our first alternative, we decided to go with a 2-story rectangular structure made of steel with 125 by 200 feet, so there's actually 25,000 square feet per floor, so a total of 50,000 square feet, with, again, the first being that retail / commercial space, and the second floor being that residential space. On the right-hand side, it's kind of cut off a little bit, but I have some of the keys for what the different spaces may be utilized for. So on that first floor, we have a nice open space, but we also have smaller offices, larger conference rooms, public restrooms, break rooms, storage spaces, elevators as well as a stairwell. And then for our second floor, we have more of apartment spaces with, again, a trash room, a fitness center, a mail / package room, and again, those same elevators and that stairwell. We decided to go with a rectangular shape for this first one because it is pretty typical for any mixed-use facility, with it being rectangular in shape and each floor serving a different utility. So we decided to keep that consistent with this first alternative design. And here we have our column design where we imagine our column spacing would be. From the AISC, it is typical for your column spacing to be anywhere between 20 and 40 feet. So we decided for those first 2 sets of columns to be 20 feet apart, and then 40 feet, and then at that last end, back to 20 feet again. But moving up and down, we have those spaced out to be 25 feet, still consistent between that 20 to 40 feet recommendation. For our second alternative, we decided to go with a perfect square shape, so that one is 141.5 by 141.5. It's going to be a little over 20,000 square feet per floor, but again, we're going to keep it consistent with it being a commercial / retail on the bottom with our residential on top. One of the differences that we have for this alternative was a nice open space here that can be used for open office space, so that can be anything similar to the senior design lab or the Christopher Center library, where you can use those for like desks, office chairs, however they may see fit being utilized for that. And again, kind of similar to the previous alternative, there's going to be the different apartments, public restrooms, fitness center, with the exception that this one does have a laundry room as well, and a mail room to pick up packages or any sort of things like that. For our column design, we decided to stay true to the inherent nature of the square being symmetrical, so we decided to keep our columns symmetrical as well, and trying to do our best to evenly space those out 28 feet apart. But of course, 141.5 does not evenly divide by 28, so there will be some slight variations, but for the most part, we are trying to do our best to keep those 28 feet apart for each column. For our third design, we decided to go with an L-shaped structure. This is due to kind of a difference in the aesthetics as far as the boring square or boring rectangular shape. We decided to do a different shape. Typically with your L shape, you kind of get the inherent nature of having 2 distinct separate wings, and with that, those can be actually divided horizontally. So you can have one wing be the residential or commercial space, while the other can be our residential. But I decided to stay consistent with the previous 2 alternative designs and still keep it where one entire floor is our residential space and one entire floor is our commercial / residential or retail space. Again, we have more shared spaces and shared office spaces that can be utilized for many different utilities or different functions. And again, we have our different apartment spacing or apartment suites. Again, the same laundry room, mail room, and along with more elevators and more stairs for the tenants to be able to move up and down between the two floors. For this one, the rectangular aspect of it is going to be 100 by 150 feet, and then the more square shape is going to be 100 by 100. For this one, again, we're still remaining consistent with the AICE or AISE column spacing guide, keeping it anywhere between 20 to 40 feet. So going lengthwise, we have it going to be spaced out 20 feet apart, with going this way is going to be 25 feet apart. As far as my future work goes, we could use the RS means data to give or derive a cost analysis for the different alternatives, so we can use that to help better identify which alternative may be best for us, and then also just working with my team to identify, again, that best alternative as far as the building location and the orientation of the structure. And I'll be passing it off to our environmental engineer.
Hi, I'm Brianna. I'm the environmental engineer at Triscuit Engineering. And today I'm going to take you through my water demand calculation, my pipeline routing alternatives, and my pipe material alternatives. So starting off, the first question is, there's nothing on the site. How do you predict the water demand? So what I went ahead and did is I assumed what types of establishments are going to be on the site, and then I assumed a percentage of land that those are going to take up. And then I went ahead and just did my normal water demand calculations, and that brings me to about 80,000 gallons per day for the average flow rate. And this is my flow rate just for the establishments. I also have to take into account the flow for needed fire. So in order to do that, I chose one of the businesses, and I went ahead and I did my fire flow calculation for that. And that gives me about 2,250 gallons per minute. So I add this value to my converted peak hourly flow, and in the end, I get a total flow rate for the entire development of 3.7 million gallons of water a day. So next, my first routing alternative is just to run my pipeline along the north side of our team's preferred road. The red lines there are the pre-existing water utilities. I do have to make it a closed loop system, so I do have to connect to them. The problem with this alternative is it's made under the assumption that every lot has access to this one road, and that's a little unrealistic. As you can see in the south section of the development, there's a lot of area there that it might not count for. So for my second alternative, I run my road along the south side, and I drop down a branch to East Summit Street. So that's going to take care of the southeast side, once again looping into East Summit Street. However, the problem with this one is that the southwest portion is once again left a little blank. So my third alternative here is to branch off from my second alternative and to connect to Maryville Road there. The problem with this one is crossing the easement the way I do. I have to make sure that that doesn't cross any of the structures and make sure it's right. So I might have to move it a little bit. These are preliminary designs. They're not 100% set yet. And then next, I'm going to go over my pipeline material alternatives. So my first one is PVC pipe, and it's the blue pipe up there. It does actually have to be blue if it carries potable water in Indiana. And then I have ductile iron pipe, which is the left picture there, and then high-density polyethylene pipe, which is the bottom right picture. So where do I go from here? So I need to solidify my dimensions a little bit more. What does that even mean? So for the existing water mains, I don't have a lot of information about them. So I know they're within the right-of-way of the road, but I need to assume where they are, how deep they are in the ground, what material they're made of, what the diameter is, and what the pressure is. So that's a lot of information I don't have that I do need, so I will have to assume those. And then I'll also have to beef up these roadway alternatives that I have already, make sure they're in the right of way. And then I'll conduct an alternatives analysis. So I'm going to hand it off to our water resources engineer.
Thank you. Okay, so my client specified that we need to create a flood control plan for the 100-year storm event, achieve 80% total suspended solids and 70% total phosphorus removal, and infiltrate 1 inch of water from all impervious surfaces. So starting with this, with every project there's some challenges. In the green you can see our wetlands, in the blue hatched area you can see the flood zone. So this will affect where I design my retention basins. So starting off with our BMPs, the City of Crown Point Stormwater Technical Manual gives us 12 pre-approved BMPs. So from this, I chose 7 for our design alternatives. Alternative 1 uses rain gardens and tree boxes. This is 2 bioretention BMP alternatives. It's good at removing total suspended solids, particulate phosphorus, and some dissolved phosphorus from the vegetation in it. Alternative 2, I use a perimeter sand filter. This is really good when you enhance it with iron to remove dissolved phosphorus. And then I have a vegetated swale to hopefully collect all my water on my parcel to my rain garden. And then alternative 3, we use pervious pavement, a filter strip, and aggregate pit. With this, I was thinking we could store as much water as possible, but this doesn't remove almost any dissolved phosphorus, so we probably won't use this. Here you can see our heat maps. I have a heat map for installation / maintenance cost and a heat map for total suspended solids and total phosphorus removal efficiency. So this should hopefully give us a good visual representation of my BMP alternatives. And then going into the flood prevention, I divided my total parcel into 3 sub-areas. Area 1 will contribute to my culvert under the road. 1 and 2 both contribute to the detention basin A, and area 3 contributes to the second detention basin. I have these vegetated swales that run along the road and along my detention or my watershed areas to hopefully get all of my water to those detention basins. And then my other alternative looks really familiar, but it uses retention basins with hold water. It removes more total suspended solids, but there is a risk for safety with this. And then future work, I need to determine my control volume, detention times, and the size of my basins. And then I have my water quality volume, but I need to do an in-depth cost comparison, water treatment comparison, to achieve the 80% total suspended solids and 70% total phosphorus removal. Any questions? Yes?
So I have a question about your vegetation swales. You want to go to that slide?
Sorry, I somehow went to the front.
I don't know what happened there.
This one?
Yeah, that one. So it looks like you have the vegetation swales on the east side where it runs. It looks like it's going from downhill to uphill. Are you doing like earth work or
Yeah,
putty
there'll
on that?
be some earth grading with
Okay.
the swales. So same thing with here, same thing in the middle, there's gonna have to be some grading to get that water to my culvert.
So where are the swales exactly? Is it just alongside the road there, or?
Yeah, it's a little hard to see. There's a vegetated swale along the road. There's one that runs right here, beside my,
Where?
right out of my culvert.
That green line there?
Yes, and
Okay.
then there's 2 that split the,
Oh, okay,
yeah.
yeah. I just-
It's hard, yeah, it's really hard to see. And
I think it would be okay if you had a legend, I think, because then I would know that the green
Right.
lines are,
this one had one, but it's still,
well, it's over there somewhere. Okay.
it's,
It's on the wall.
it's on its way.
Okay. So Andre, I got a couple questions. One is, I had 2 and I remember 1 now. So, first one is your heat map with the boxes
Yes.
for, so the sand, the rain garden is going to remove more phosphorus than the sand filter with iron?
I did this one without iron,
Okay.
but this was for total phosphorus also, so I was thinking about particulate and dissolved. So
Yeah.
particulate phosphorus makes up 0 to 100%, roughly 60% most of the time, so
Yeah.
I was thinking it would remove more than the sand filter.
If it doesn't have sand, if it doesn't have iron, it might, but so I don't know if you're gonna have iron in it or
We
not.
will, I
Yeah.
think.
Okay, okay, and then, Could you go down a couple slides? Maybe it'll jog my memory if, that's it? That's the end of your slides? Maybe it'll come to me, I don't know.
I got one there, and I'll save you the question from Professor Algebra. Your water quality volume acre feet, what kind of number is that? Just a second.
I was, yeah.
I mean, 0.1 would have been fine. That many decimal points just doesn't make any sense. But that's just to note that while we're on that slide. Other questions, or you have?
No, I haven't thought of it yet. Let's come back.
Christian, on your load slide, I didn't see anything like snow, wind, where does that stuff get calculated in?
Yeah, so I use the ASCE hazard tool to derive those numbers, but unfortunately I did not place it
Not
into our
in here yet,
presentation.
okay.
But those numbers are calculated, or are provided.
Okay. I have one question for Brianna.
Yes.
What did you find to be the most challenging part of this project so far?
Definitely the amount of assumptions I'm working with. I have to assume realistic values, but me personally, I don't have a lot of experience. A lot of these things are new to me, like calculating the needed fire flow. So I've definitely been in Professor Algebra's office asking what's realistic, what's unrealistic, and he's been helping me along with that process.
Thank you. I couldn't come up with any questions for the transportation stuff. It seemed good.
Well, if I think of my question, Andre, I'll email it to you. And I'll expect an answer within 3 minutes, how's that? Okay,
Okay.
thanks.
Thank you.